Alright, good morning guys. I wanted to record this little video. We're going to go through our notes for today, and then I'm also just going to talk about kind of what the plan is for those of you that are at home. So first thing today, what I want you to do is to take this quizzes. It's due by 3 p.m. so it expires at 3 p.m. Make sure you do it before then. It's just a little review of our Learning Target 8 quiz that you took before break. I do have those graded, and if you would like, I can take pictures and send you your scores. Just send me an email asking for that, and I can do that. The notes then on pages 1 and 2, if you open up the notes packet, you can either print those if you can at home, just the page 1 and 2 for now, and then you can use this video to help you fill them out, or you can make a copy of the notes packet and type on it and save it that way, or you can just write it on scratch paper, kind of up to you there. Tomorrow and Friday then we will do a Pogle on periodic trends. Again, you can either print that, it's linked there for you, or you can write your answers on a separate sheet of paper. If you know of other people, I can't tell you who else is at home, but if you know of other people, feel free to set up a video call with them and work through the Pogle if you would like. The collaborative practice on pages 7 and 8, it's actually on pages 7 and 8 in that notes packet that I linked above. So you can go ahead again and print those 2 pages and work on those, or write them on a separate sheet of paper. And then the retake for Learning Target 8, email me for the code if you would like to do so. That retake is going to replace your score if you score higher, and it will be averaged with your score if you score lower. The following week then we will review quarter 2 content on Monday, and then Tuesday and Wednesday you have an interim assessment and your Learning Target 9 quiz, and I'll talk more about that in a video I will post on Monday with your review content as well. Okay, so let's go ahead and get to the notes. Let me go ahead and present this. That's the same link that you guys have. Oh, it's a little too big. How do I make that fit? Let's do this instead then. Sorry guys, 1 second. Oops. It's not fitting on the screen. All right, well, let's just do it this way then. Oh, wait. Little trick from last year. There we go. Okay, now you can see everything. Okay, so we're talking about Coulombic attraction today, or Coulomb's law, and it's the attraction between oppositely charged particles, and in this case we're talking about protons and electrons. Coulombic attraction is measured in newtons because it is a force, and so this is essentially a summary of that virtual lab that you did for homework before break, and I reopened it for yesterday. So the 3 things we're looking at with Coulomb's law, or Coulombic attraction, is charge, which is represented with a Q in this picture, force, which is our big capital F, we've talked about force before, and then this R. R is representing the distance or radius between the 2 charged particles, so in this case the distance between the proton and the electron. And so there's some relationships we can talk about related to charge and force, and distance and force, and that's what you did in your virtual lab, and then we're just going to summarize. So the first thing we're going to look at is the relationship between distance and Coulombic force. So in this model you can see we have A, B, and C. We can see that the distance is increasing between A, B, and C, and if we look at the force of attraction, what is happening there? Decreasing. So we can say that as the distance between the particles increases, the force is going to decrease. Let me move my little picture. So again, as the distance between the particles increases, the force of attraction decreases. And so we're looking at distance and force. Which of those three variables are we keeping constant then? Charge. So if you look, we have one positive charge on the left side and one negative charge on the right side. We're keeping charge constant while changing distance and seeing how it affects the force. So let's graph that. What does that look like in a graph? I know graphing, we're back to it, we're never going to leave it. I'm going to attempt to write on here, we'll see how it goes. So for graphing, our independent variable in this case is going to be distance. Okay, our dependent variable then is that force. So what happens to the force as I change the distance? What's being held constant then is charge. So independent variable is going to go on my x-axis. Sorry about my handwriting, guys. It's terrible with this little pen thing. I'm just going to write force with an F there. And so the relationship we saw was as distance increases, force decreases. So we have an indirect relationship. Okay? As the distance increases, force decreases. An indirect relationship between those two variables when charge is held constant. Good? All right. So let's take a look here. We have three elements. We have lithium, sodium, and potassium. If we look at the periodic table, those are all in our first column on the periodic table, right on top of each other. Notice that they each have one electron in their outer energy level. And if we write their electron configurations, you can see that they have that one electron in that S energy level. Notice, however, that that energy level is increasing. So in lithium, that outer electron is in the second energy level. In sodium, it's in the third energy level. And in potassium, it's in the fourth energy level. So what we're looking at here is as we move down a column on the periodic table, what is happening? So as we go from lithium to sodium to potassium, what is happening to our force? Well, the distance is increasing, right? So the distance between this electron here in lithium and the positive nucleus is much smaller than the distance between this electron in potassium and the nucleus of potassium. So because the distance is increasing, it's getting bigger, the result is less force because of that indirect relationship between distance and force. So if we look at a column on the periodic table, we can say that electrons are getting further away from the nucleus, which is going to decrease the force of the nucleus on those electrons. And so that's kind of our first trend that we're going to be looking at here, is the difference between going up and down a column on the periodic table. The next one we're going to look at is the relationship between charge and Coulombic force. So charge then being, look here, see that this time we're keeping distance constant. Everyone is 0.10 nanometers apart, but we're increasing the amount of protons that we have on each one. So A has 1, D has 2, E has 3. So as I increase the number of protons, what happens to my force? It increases. So this time, increase charge, increase force. So as the charge increases, the force increases. We call this a direct relationship to each other. So the more protons you have, the stronger that force. And that should make sense. You have a strong magnet and a weak magnet, it's going to pull harder than if you have two weak magnets with each other. You can use magnets to also think about distance. The closer you bring magnets together, you can feel that force of attraction stronger until they're stuck together. And the further they're away from each other, that force of attraction is much less. So let's graph this one as well. My terrible handwriting. So in this case, our independent variable is going to be charge. As I increase charge, what happens to force? While keeping distance constant this time. I always need to have, distance I always need to have a constant variable. So in this case, charge, again, being my independent variable, is going to be on my x-axis, while force is going to be on my y-axis. As charge increases, force increases, and that is going to be a direct relationship between those two variables. All right, I need to make this less than 15 minutes, so let's hustle up. The trend then that we're going to look at with charge is as you move left across the periodic table, so from left to right like we read, what happens? So if we look here, we have sodium, aluminum, and chlorine. Sodium is going to be on the far left-hand side in row 3, and aluminum is going to be kind of in the middle in row 3, and chlorine is going to be on the far right next to the noble gases in row 3. So they're all in the same row, so they have similar amounts of electron energy. So notice that those outer electrons are the same distance from the nucleus. But what's different here is that I'm increasing the number of protons. So as I increase the number of protons or increase the nuclear charge, I'm increasing the Coulombic force. So if you look, sodium has 11 protons because its atomic number is 11. Aluminum has 13 protons because it's number 13, and chlorine has 17 protons. So 11, 13, and 17. We're increasing the amount of protons, which is going to increase the amount of force. We're increasing charge as we go from left to right across the periodic table, which is going to increase that force as we move from left to right across the periodic table. These concepts, the relationship between distance, charge, and force, is going to help us explain different properties of elements that we'll get to in class next, or in the POGO activity. So we're talking about those 3 relationships. You're either talking about the distance as you go down a column, or you're talking about nuclear charge as you go from left to right across the periodic table. So to summarize that, I have this little periodic table here. I'll actually just link a picture of what this looks like when I draw it out in class. It's going to be too hard for me to do it in this little video here, but I will link this in the how will I do that? I'll link it below the text in the planner for you guys, so you guys can sketch out what we sketched on this periodic table in class. Again, if you have questions about this, please send me emails, ask as many questions as you can, and we can always set up a quick video call to chat about it when or if you need it. Okay?